All right, welcome back everybody. Today's lesson is on sedimentary rocks. We just finished up igneous rocks. Remember, the rocks made from molten rock cooled off into solidified rock. Sedimentary rocks are a little different. These rocks are not formed by melting and solidification. These rocks are formed when other rocks, broken bits of rocks, compact, perhaps cement together with natural cement. That's one way. Another way is they could precipitate from seawater. This means they literally, the seawater becomes so concentrated in a certain type of salt mineral that it settles to the bottom of the seafloor and forms layers of rock. And third, these rocks can form from the accumulation of organic material, once living things, whether it be little tiny dead bodies of creatures on the bottom of the seafloor, or coal, where there used to be rainforests on the land. And the rainforest areas, they eventually died off, climate change perhaps, and formed layers of organic rock like coal. Sedimentary rocks are different than igneous rocks in the fact that they're not as thick, as far as the earth goes. They're usually formed as a thin coating, or we like to say veneer, on top of other rocks. Kind of like the dust on your windowsill or the dust on anything in your bedroom that's a flat surface. It forms over time, and it builds up layers, and if you let it go for a long time, well, the dust in your bedroom, it gets thicker and thicker and thicker. And so that's how you can think of sedimentary rocks, as a layer on top of the other rocks underneath them. Running water is the most important agent that forms sedimentary rocks, and it forms these rocks usually in horizontal layers, as you see in this rock picture down here. You can see the layers. There's a layer, kind of like a cake, another layer, another layer, another layer, another layer. And so sedimentary rocks you've probably seen in road cuts around town or out in on the highways, because you can see the layers. The three groups that can be you can form sedimentary rocks into are kind of what I just mentioned in the last slide: the clastic rocks, the crystalline rocks, and the bioclastic, which are the organic rocks made from the dead things. But in all cases, these rocks somehow originate either underwater or in the presence of water. Their composition, for the clastic rocks, they're always made of fragments of other broken rocks. They're not made of dead stuff. They're not made of salts, at the bottom of the seafloor. These are made from literally rocks that are broken up and glued together to form another kind of rock. Crystalline rocks, sometimes called chemical rocks, these are the salt rocks. These are rocks like rock salt or gypsum. We'll talk more about that later on. But these rocks are made of usually of one type of mineral on the bottom of the seafloor. They're called monomineralic because it's one mineral. The bioclastic or organic rocks, these are the once living remains of things. That's what they're made of. So you might see, coal is made from the once living plant material. You might actually have a rock called coquina, which is made of once living shells, the shells from once living clams. Method of lithification, this is simply how the rocks were formed, the method that they're formed. This is important. We're going to use this in lab class. And let's see if we can get this to show up. There we go. For clastic rocks, these rocks are always made when nature compacts them and then cements them. So that's the method of lithification for a clastic rock. For the crystalline rocks, these rocks are precipitated, which means they fall out of solution, out of the liquid, and or they are evaporated when salt water, perhaps a shallow saltwater ocean or lake, evaporates, and the salt can't evaporate up into the sky and it's left behind. Or the third one, the bioclastic organic type rocks, the compaction of dead stuff. So if we take a look at your Earth Science Reference Tables, page 7, you can get those out now. We can actually find these rocks on page 7. There's no pictures on page 7, but you can look at the rocks and find out their characteristics. The rock on the left has rounded fragments. On the right, it's angular fragments. So these two rocks have similar compositions, perhaps, similar method of lithification, but they're named differently because of the shape of the fragments that make up the rock. So here they are in the reference tables. You can see these are clastic rocks. These are rocks made from fragments of other rocks, and they are pebbles, cobbles, or boulders perhaps, embedded in sand, silt, or clay. The composition, mostly quartz, feldspar, and clay minerals. Those are the most common minerals on the Earth's surface. That's why that's there. And the first rock with the rounded fragments is conglomerate. You can see the rounded fragments. They call it conglomerate. And there's even a picture here which kind of looks like the rock in that last photo we saw. Okay, moving on. The other rock was also clastic. It was made of similar sized pieces, similar composition, but had angular fragments, so it's named breccia. And the picture there shows kind of what it looks like. Some people say breccia, some people say breccia. And there's the names, conglomerate and breccia. Moving on, another rock. On the left, we see sand-sized fragments. But on the right, if you look under a microscope, these are clay-sized fragments or sediments. So now let's try to identify these two rocks. If you look close on that rock on the left, you might even be able to see very thin layering. Sand-sized and clay-sized. Where do we go from here? Let's go back. You see the sand. It's clastic. Sandstone makes sense. Picture kind of looks like it. And if we see clay, it's called shale, and the picture kind of looks like the layers in shale. You'll notice that sand and clay have definite sediment sizes. These are definitions of how big those particles have to be, or how small they have to be that particular grain size, that name. And so that is sandstone on the left and shale on the right. And we have a lot of shale around here where we live, for those of you listening in Fort Plain. It's a very common rock in this area because this area was under a shallow ocean, 350, 400 million years ago, and a lot of layers of clay built up on top of each other to form shale. Okay, the next rocks, we have some shell fragments in this rock, and we have lots of salty tasting crystals in the rock on the right. What could they be? Well, now we're going to be on a different section of the sedimentary rock chart, not the inorganic, never was living, land-derived, broken up rocks kind of section. We're going to be down here in the chemically and or organically formed section. Okay, so if we take a look, the first one, it had bits of little broken rocks in it, or broken shells in it, and you can see where those are in the chart. We call that bioclastic because it has bits of shells in this case, shell fragments. And that rock would be considered limestone. It's a form of limestone. You can see the picture looks kind of like bricks. Okay, the next rock. Oh, before we go on to that, that rock is made from the mineral calcite. And you guys remember from lab class in the minerals lab, calcite's a really easy mineral to test for with just a drop or two of hydrochloric acid. Don't forget the goggles. If it fizzes, you know you have it. So that's limestone. Now the other rock up there on the right-hand side was definitely crystals that are salty tasting. And I think you can see where we're going with this. Halite's a mineral that tastes like salt. If you remember from the back of your reference tables, halite's on there. And therefore it's rock salt. And its symbol looks like graph paper. All right, hopefully you get that. So there's rock salt. We mine quite a bit of that in New York State. Okay, back to your notes. Key processes. These are the things we kind of talked about in that first slide. The rocks that are clastic are made by compaction and cementation. Sometimes in lab class especially, you're going to see this is called lithification, the way the rock was made. The three minerals that glue the rock together are typically calcite, silica, and iron oxide. Calcite You're going to see the acid test. It's going to fizz. Iron oxide, often you'll see that as a reddish color. That's been oxidized or rusted. And the silica, you won't see much of a change. Typically rocks like sandstone made with silica cement are very strong. Okay, examples, shale, sandstone, conglomerate are great examples of those rocks. All right, the next key process, evaporation, the evaporites. These rocks form from, remember, the salt water evaporating, sometimes precipitating, to form monomineralic crystalline rocks, one-mineraled crystalline rocks. Rock salt and dolostone are two examples from your reference tables. Precipitation from seawater, the falling out of minerals because of a high concentration of salt in that water, and they will settle to the seafloor and form layers eventually. Rock gypsum is a great example of that. Even limestone around here is a great example of that, even though your reference tables makes it kind of difficult to understand. And one thing you always want to remember is sedimentary rocks always, not always, but sedimentary rocks are usually, almost always, the rock family that has fossils in them. So if you see a fossil, usually you're looking at a sedimentary rock with that fossil in it. And you might remember what that thing is. After this video is over, maybe one of you can share the name of that thing and why it's special in New York. All right, and that's it for today.